Now, these are the steps to follow when building on a main model. The first is to define the problem. Defining the problem means that, like for example, if you want to build a house, you will need to know the kind of a house you are building. For example, if you want to build a house made of bricks or a house made of wood. Like for example, if you choose to build a house made of bricks, you will require some tools like the cement, the window. Now, the cement and the window and all etc. things. That's like now you have known the type of a problem you're working on. The problem here is to build a house made of bricks, and the cement and the window is the collection. That's now our collection, the tools we are going to use. So we go to step 2, that's the data collection. Data collection now, as we have said, we have collected our tools to build the house, like the cement and the bricks and the window, all those kind of things. So we do the data collection, and in our model, when building our model, you may need to have some skills like the web scraping skills. Web scraping skills, this where you can scrap the data or information from a website. So the libraries you can use to do that is for example, you can use Beautiful Soup, Selenium. You can use the other one called, there's Octopus, Pepperstone. Yeah, again, maybe your data is, you can also collect that data you want to use for your model from the Kaggle. Kaggle is where you can readily collect for free your data. So after you have done our data collection, you can do data preprocessing. Data preprocessing generally means we can clean our data. Clean our data is to remove the outliers in our data, to handle missing values. So generally, data preprocessing means that we clean our data set. After data preprocessing, we do feature engineering. This is the step 4. Feature engineering now. This is where you can do some feature selection. Like for example, we have done our data preprocessing. We have cleaned our data, but you can find that our data set includes some features which are not in numerical terms. So you can do some encoding to our features. That is to make our features to reduce some our features from categorical features into numerical. And one way of doing that is by using the one-hot encoding and label encoder. The difference between one-hot encoding and label encoder, like in one-hot encoding, you will change from categorical features to numerical features when the features are two. Like for example, you may find that in our dataset there's the categorical features in terms of yes or no answer, or in gender based like male or female. So you can change the male into 1 and the female into 0. Yes, you can change the yes into 1 and the no into 0. Again, one-hot encoding is when the features are more than 2. Like in label encoder, we only had 2 features, like yes or no, male or female. Yeah, but in one-hot encoding, when the categorical features to be changed are many, like for example, you can find a column with countries like Spain, England, Kenya, Nigeria. You can change those into numerical. So you can change maybe Nigeria to be 1 and the rest to be 0. So basically one-hot encoding changes. You can use one-hot encoding when you want to change features which are more than 1, categorical features which are more than 1. Again, you can do some dimensionality reduction. You can do dimensional reduction is when the features are so large, so you want to reduce the feature space. Reducing the feature space by retaining, and when you do feature reduction, when you reduce the feature space, you will retain some important information. It's not like you are reducing the feature space and some important information will be lost. No, you will retain some important information. That's now the using dimensional reduction. One technique of dimensional reduction is to use the PCA, that's the principal component analysis. Again, you can do some preprocessing, like using min-max scalar and standard scalar. The difference between min-max scalar and standard scalar is that min-max scalar, in case you have your data set having some numbers which are so large and you want to change them into one scale, you want to scale them into one scale, like from 0 to 1. So what min-max scalar does is that it changes your features into one scale, like from 0 to 1. It will reduce, for example, if you had your features starting from 0 to 10,000, so the 10,000 will be reduced into 1, and the smaller values will tend to be closer to 0. So the standard scalar means it's like the z-score. It's the normalization. Normally we were talking about that one you have heard that one mostly in college or in high school. That the z-score. Z-score, what it does is that it normalizes your data. So it will make your data, all your numerical values, it will tend to be closer to 0. And the formula for that, you can get it from the formula. That's the x minus mean over the standard deviation. Now we'll dive into more details about that, but this is just the theoretical part of the steps to follow when building an ML model. So after doing that, the standard scalar, the min-max scalar, the dimensionality reduction, we can now go to model selection. That's our step 5. Model selection, you can choose an algorithm to use in your model building. There are many algorithms out there. Like the most common ones are like the linear regression, logistic regression, random forest, decision trees. Those are the bagging techniques, and they are also the boosting techniques, like the XGBoost classifier, XGBoost, and the CutBoost classifier. So you can decide to use the bagging techniques or the boosting techniques. Okay, now that, let's assume now we have done model selection, you have chosen an algorithm, so you will now train. We'll go to our step 6, which is the model training. In model training, you will need to split our data into the training set and the testing set. The reason we do that, and testing set is like individual data sets. It's like an individual data set that our model has not seen. The reason we do the splitting is, for example, maybe is to reduce overfitting. And overfitting comes when our model does well in training datasets but fails to generalize in our testing dataset. So when you find that our model is overfitted, you can choose maybe to collect more information or more data, so that you can retrain your model. So you'll start from the beginning, from data collection all the way. So you'll collect more data. Again, apart from collecting more data, you can do some hyperparameter tuning. You can tune your model. So now you have done with our model selection, model training. You can now evaluate. We move to our step 7, that is the model evaluation. You can evaluate your model, the performance. This is now evaluating how your model works. So there are some metrics you can use in your model evaluation. The most common ones are, like, for example, the MAE. That's the mean absolute error. That's now the difference between the predicted and the actual. You can use the mean squared error, and the root mean squared error. Root mean squared error is just a root. You just do the square root of the mean squared error. There are others like accuracy score, F1, recall, precision score. There are many. There's another one called AUC. That's the area under the curve. So it depends on your model, and you can choose the best metric. Again, since we have done our model selection, model evaluation, you can now deploy your model into an environment space. So since we are satisfied with how our models work, we can deploy our model into an environment. Like, you can deploy a model into AWS. That's a free source. You can deploy them. The reason we deploy them, our model, is for updating. Like, for example, if you are working in a project, like a project for detecting the fraud. Yeah. So when the techniques, the people who are involved in fraud, when the techniques they were using changes, you will need to update that model, the working of that model, to capture the new techniques the people who are involved in the fraud are using. So the reason we do deployment is for monitoring and updating our model. So to wrap up, what we have said is about the steps to follow when building an ML models. These are just the steps. This is the theoretical part. We'll go in depth. So we have said the first step is to define the problem. The second one is data collection, data preprocessing, feature engineering, model selection, model training, model evaluation, and deployment. So in our next step, we will dive into each in depth of each one. Like, for example, in our model selection, we will talk about each algorithm, the working of each algorithm, the mathematics part of each algorithm, so that we understand better. So I hope you enjoyed. You can like and subscribe to our channel. I sign out.